In this video, we are going to learn how to write a polynomial in factored form. So we're going to write each polynomial in factored form, and one technique that definitely stands out, we'll use it with this first example, is you always look for a greatest common factor, which in this case they all have x in common, so we'll factor out x first. When that gets factored out, we now have x squared minus 2x minus 15. You'll notice that once we factor out that x, this is now just a quadratic, which we can factor using quadratic techniques, meaning look for two numbers that multiply to negative 15, but then add to negative 2. So what two numbers multiply to negative 15 and add to 2? You can try a bunch of different combinations, but it's going to end up being 3 and negative 5. 3 plus negative 5 is negative 2, so that combination works. So when I factor, I'll get x, which is still already sitting on the outside factored out, times x plus 3 times x minus 5. Now, along with factor out the greatest common factor, sometimes your leading term will be negative, and it's also another good factor to take out is that negative. So here they all have an x in common, but I'm going to take out a negative x. So I'll have negative x times x squared, now minus x, so it goes down by 1 power, but since I took out a negative, the plus becomes a minus, and then the positive 12 also becomes a minus 12. With the x factored out. And the way that works, if you imagine that negative going back in, these would turn back to positive, or imagine just dividing by negative x. That positive would turn negative. And again, I can factor it in the same way I just did in the previous step by looking for two numbers that multiply to negative 12, but add to negative 1. So the two numbers that multiply to negative 12, but add to negative 1 are going to be 3 and negative 4. 3 times negative 4 is 12, and then 3 plus negative 4 is negative 1, so that works. So the way our quadratic will factor is x plus 3 and x minus 4. And again, that negative x that I factored out at the beginning is part of my factors. Now, my top right example, I see here there isn't a common factor amongst all the terms, because they don't all have x's, nor do they all have coefficients. But I'm going to teach you a technique I like to use called factoring by grouping, which we have used before with quadratics, but in this case, there's already 4 terms, so we just group them 2 and 2, and we see if we can find a common factor this way. In our first group of the two terms, the greatest common factor is x squared, so I'll factor out x squared, and when I factor it out, I'm left with x plus 3. In my second group, they both have a 4 in common. The 12 doesn't have an x, so I can't say x. So I can factor out a positive 4. And when I do, I'm left with x plus 3. So both groups have a factor in common, which is x plus 3. So now I can factor that out of the entire expression. And when that's factored out, I'm left with x squared plus 4. Which is the sum of squares, which if I were to factor this would give me two imaginary factors. So I'm going to stop there, because typically when you're just looking for the factored form, you want all of your factors to have real numbers in them. But in a follow-up lesson, I'll go over why we sometimes want to factor x squared plus 4 as well. Next up, we have x to the 4th minus 12x squared minus 64. Again, no common factors amongst all the terms, and this isn't a quadratic. But there is a technique I can use where I substitute in another variable to factor this. So I'm going to pick a, but I'm going to set it equal to x squared. And the reason why that's important is this expression here can be written as x squared for my x to the 4th minus 12 times x squared minus 64. And if I replace the x squared with another variable, I end up getting a squared minus 12a minus 64, which brings us to a quadratic like I wanted to have before. And once I factor out this quadratic, I can substitute the x squared back in. But I can bring it to a quadratic first. So how does this quadratic factor? Well, I'm looking for two numbers that multiply to negative 64 and add to negative 12. That would be 4 and negative 16. 4 times negative 16 is negative 12. And then they add together to give me negative 12. So the way this expression factors with the a is a plus 4 times a minus 16. So now that it's factored, what I can do is I know that a is equal to x squared, so I can put the x squared back in for a, and that'll give me x squared plus 4 times x squared minus 16. So that's one way I could have factored that expression. Now again, I have that sum of squares just like before, but I also have a difference of squares, which is factorable with real numbers. So I'll get x squared plus 4, but then times the difference of squares factor of x squared minus 16, which would be x plus 4 times x minus 4, using those conjugate pair to get that. And that is how you write a polynomial in factored form.